Hello everyone and welcome to our new webinar, Airborne Hyperspectral Imaging over hops. I'm pleased to have you on the line with us today. My name is Francesco Beccari. I'm the EMEA sales manager for Headwall Photonics, and I welcome you to this event. Just a few rules about this webinar. This webinar is being recorded and all the recording should be available within 48 hours from the end of this event. We will try to answer as many of your questions as possible during the live session, during the Q&A session. However, any unanswered email will be treated through our email discussion. And please don't hesitate to send your further questions to marketing@headwallphotonics.com. But we'll try to answer as many as possible during the event itself. The agenda today is very interesting, very rich. I'll give a brief introduction to Headwall and to the CHRSE, the Center for Hyperspectral Remote Sensing in Europe. And then I'll give the floor to Florian Weiss, Daniel Hajek, whom I will present later on, and they will also introduce themselves. And then we'll kick off a Q&A session and finally a wrap up. Okay, so how should you ask a question? It's easy, just look at the right side of the screen. It should be on the right side of the screen. There's a specific button to express a question. We will read that and we'll comment that during the Q&A session. Or use that area even to report any problem, any issue listening to the event. Okay, so here's our board of panelists, a very rich one. We got a very interesting panel today. There's Florian Weiss from the Bavarian State Research Center for Agriculture, LFL. Daniel Hajek from the Catholic University of Eichstätt, and Johannes Seidl-Schulz and Christoph Schimmer, Produktspezialist at geo-konzept. They will introduce themselves further when it's their turn. But let me welcome you to Headwall and the CHRSE in very brief detail. Headwall is an American company founded in 2003 and growing in volume because we've been acquired recently by Arsenal Capital Partners, and we have expanded our galaxy by acquiring Holographics, a microreplication grating center in Marlborough, Perclas, which is also our machine vision center, developing Perclas Mira software for hyperspectral data analysis based in the Netherlands, and eventually today, just recently, Innospec, our friends from Nuremberg, Germany. Headwall, in its headquarters, hosts more than 100 highly skilled employees and more than 40,000 square meters facility where we host design, engineering, research, production, and delivery. So everything happens here in Bolton, Massachusetts. Next, please. Okay, so just to show you how Headwall has verticalized its main business units, 3 main business areas have been outlined by Headwall. The machine vision area, let's say everything that is measured from a lab perspective or directly on the line. The remote sensing area, and we are talking about remote sensing today actually, so everything that happens under the sun, so UAV, even space, aircraft, ground-based measurements. And finally, another very important section of Headwall, the OEM business, diffraction gratings, spectrographs, and much more. But as I said, today we are in the remote sensing domain, of course. In a nutshell, what is our focus for you customers? We develop spectral imaging solution, high-end spectral imaging solutions, both for end users and OEM customers. We really put special effort in supporting and training our customers, both virtually, remotely, and directly on site. And what we also love to do, as we are doing today, we love sharing our knowledge. So please visit our website and land on the following page, this page, the library page, where you may find a lot of available scientific online content regarding hyperspectral imaging technology, our products, our data sheets, a lot of application examples, a lot of customer publications, all the recordings of the past webinars, including this one, when it will be over, and a lot of demos, tutorials, training refreshers, and much more. It's a very rich page with a lot of content. Okay, so this said, I leave the floor to Johannes Seidl-Schulz for the introduction to geo-konzept. Thank you very much.
Thank you, Francesco. So I will go on. My name is Johannes Seidl-Schulz. I work for geo-konzept. Geo-konzept is a precision agriculture company. So basically we equip tractors and machinery to drive with GPS steering systems with a high accuracy with RTK precision. We also have field robots, sensor and measurement devices, and so everything that touches the area of precision agriculture. So we are existing since 1992, have roughly 60 employees now, and we are located in the center of Europe and in the center of Bavaria, the heart of Bavaria. Besides precision agriculture, we have also a spin-off, I would say, a blasting solutions department. That's because we have scanners and GPS devices, and there's a lot of synergy to all our other solutions, and therefore that over the years it developed quite rich, and we have software solutions there as well. So this department is growing as well. And me and my colleague Christoph Schimmer, who you also see in this webinar, we are employed in the remote sensing department. We are dealing with all types of drones, the more smaller ones, general ones, the bigger ones, or even vertical takeoff and landing drones. And we try to combine those drones according to a specific task and bundle it together with the right fitting software and provide training in our facilities, or we do project and service flights. So that's how we come into play here at this point. Together with Headwall, we formed the Center for Hyperspectral Remote Sensing in Europe, the CHRSE. And our goal is to make hyperspectral data, hyperspectral remote sensing accessible. Basically to everyone. And therefore you see our facility here in the upper left corner. That's where we offer workshops, training sessions. You see there's a lot of green area surrounding us. So there we can perform good flights, show demo equipment, and we also have training rooms where we can hold workshops and training sessions in general. And also we perform project flights or service flights like we did in this case. Our topics where we see hyperspectral imaging can be of interest is agriculture and phenotyping in field trials, environmental monitoring, infrastructure inspection, and as I said, mining already. Those are the topics that we see, among others, that hyperspectral imaging can really be helpful and can be of interest. That's the goal for the center, so to hold workshops to show and to get access to hyperspectral data. Here you have some impressions from previous workshops. And just stay tuned. We will hold another workshop this year in autumn. So there will be workshop time again. And feel free to join there. It will be 1-2 days with really live flights where you can see how the data is gathered. You can see what you have to pay attention to. You can see the pre-processing of the data and afterwards the post-processing. And we also see applications and scientific publications. It's always a good mixture of actual practical use of the data and theoretical publications that have already arisen out of the use of hyperspectral imaging. So this is how we come into the project. Me and Christoph, we were flying for Florian Weiss and the Bavarian State Research Center regarding these HOPS canopies. And Florian, we were flying according to their wishes, according to their demands, and Florian will go into further detail what were those tasks, what were the targets of those flights. So Florian, the stage is yours.
Thank you very much for introducing. My name is, like Johannes already said, Florian Weiss. I work at the Bavarian State Research Center for Agriculture. We do all kind of agricultural research in Bavaria for all our crops we are cultivating. I work in the hop department, so we are specialized in hop research. And I will give you just a short wrap up about hops in general and how we started to use the remote sensing. So hop is a perennial crop, so it grows every year. Only the female hop plants grow the cones which are used for brewing beer. So the production takes place in fields so-called hop yards, and the hop plants grow 7 meters in 70 days. That's one of the fastest growing land plants. So we deal with 7 meter high plant most of the growing season. On the next slide, I will give you a short overview of the most important pests and diseases. On the left, there are our fungal diseases, downy mildew and powdery mildew. On the right are hop aphids and spider mites, the two most important pests. Economically, they are most relevant due to their high damage potential. They occur annually with varying intensity depending on the climate of each year, and they are to control with integrated pest management. The pest management is necessary to produce hops in high quality for brewing. Otherwise, the brewers would not take them for their product. A further reduction of the plant protection products is demanded by the public and also the government, and we hope our high standards can be further improved by remote sensing technology, which we are currently testing, but more on this topic later. On the next slide, I will give you a short overview over our severe hop diseases. They are also economically relevant due to their high damage potential, which is building up year for year. The plants in these cases stay infected and infectious until the death of the plant, and they cannot be controlled with any known plant protection product until now. On the bottom right, you can see CVCVD. It's a virate. It's occurring in the Hallertau since 2019, and here the plants are growing stunted and they don't reach the full height of the 7 meters, so which led to in decreasing yields and important contents of the cones for the brewing process. On the left side, there is verticillium. It's a soil-borne fungus. Sorry, one slide back, please. Can you just skip back to the severe hop disease? Thank you. It's a soil-borne fungus. It's occurring since 1952, and since 2005, there is a more aggressive strain spreading, even infecting our tolerant varieties. There is a still ongoing research project on verticillium, and this research project also led us to remote sensing. Next, I come to a different department on our hop research center, hop breeding. On the next slide, our breeders were also very interested in remote sensing and hyperspectral imaging. So we tested it on different hop varieties in our field trial. As you can see, there are differences in reflection between some of the varieties, but Daniel will give you some more detailed information on this topic later. So on the next slide, we just jump into the remote sensing in plant protection. In the plant protection department, we had to validate a new application rate system for the conversion of plant protection product from other plant types like grapevines or apples. So we can import plant protection products from those cultures to hops in the future. Therefore, we used LiDAR data to measure the cross section. We counted the pixels and calculated the cross section per hectare ground surface. Afterwards, we compared the cross section area with the measured leaf surface area, as well as the calculated area, which has to be treated with the plant protection products, the so-called leaf wall area. As a result, we got pretty high correlations between all three of these values. The cross-section area is nearly 100% the same surface as we calculated for the leaf wall area, so we were able to demonstrate the connection between the calculated and the measured values to our official authorities. On the next slide, we come to the verticillium build, the research project that brought us here to remote sensing, where our single plant assessment for verticillium takes a lot of time. And for the best treatment and early detection of infected plants is extremely important for us, so they can be removed as soon as possible to prevent the soil-borne fungus from spreading. We used the hyperspectral imaging data measured by a Headwall sensor mounted to a multicopter. We need the high resolution because we only get about 4,000 plants per hectare, so we currently cannot use hyperspectral data captured by the satellite. maybe in the future it is possible to use those pictures with increasing resolution, but the currently available 10-meter resolution is not suitable for our use case. We also need to distinguish the hop plants from the soil, respectively the intercrops growing between the rows. They are grown there to reduce the erosion. So our vegetation index was validated by additional data collected through conventional assessment, and to use it on a larger scale in trials and in concealing, we have to further develop the method. So the research on this topic has only started, and we will continue here. On the next slide, I'd give you a short insight in our project we had last year. In 2023, we also continued our research on remote sensing by drone, but we worked on additional research project where we had a stationary hyperspectral sensor to achieve control conditions. There we used the Headwall MV.C V-near staging stage plus per class mirror. In this trial, we made experiments on the early detection of the citrus bark cracking virate, powdery mildew, and spider mites, and we would like to be able to early detect those pests and diseases similar like we try to detect verticillium. Since the plant is affected, we believe we have a chance to measure changes in the reflection by hyperspectral imaging and calculate a hop-specific index for each of the diseases. Here we are also still in the beginning, and we did not properly analyze the data until yet. On the next slide, we come to the opportunities and challenges we had so far. So these were just our first steps on the topic of remote sensing. We recognized some obstacles like the shadows inside the hop yard because of the plant's height, and also when the direct sunlight, when the sun is not at its zenith. We also underestimated the required expertise for the evaluation of the data. Thankfully, we got into contact with the University at Eichstätt, who also cooperates with geo-konzept. Nevertheless, we believe in the opportunities like non-destructive observations and big observed areas may become automated in the future, especially on the high work rates. They are important for us, since because of climate change and globalization, it's only a matter of time before the next pest or disease is arriving in the Hallertau. And with the help of remote sensing, we are hopefully able to monitor the spread. At the end, I would like to say thank you to our partners from geo-konzept and the KU Universitat. Thanks for your attention, and if there are specific questions, feel free to ask me or contact me by mail. Now Daniel will continue. I think his talk was pre-recorded, but he will be here here later for the Q&A.
Well, as you can see, my name is Daniel Hajek. Right now, I'm still a geographic student in Germany at the University Eichstätt-Ingolstadt. And right now, I'm doing my master thesis, which is themed as you can see on the screen. It's leaf physiological differences between 6 hops species using hyperspectral UAV data and terrestrial chlorophyll measurements. At the beginning, I want to present you the study area. It's in the southern Germany, southwest of Ingolstadt in Bavaria. The region is called the Hallertau, and the exact spot is called Stadelhof. My cooperation partners for this, for my master thesis are the Hops Research Center in Hüll, that's Florian Weiss and Katholische. And as there is geo-konzept in Adeschlag, there's Johannes Schulz and Christoph Schimmer, my corresponding partners. On the DOP, you already can see the explicit study area. It's all around about 12,500 square meters, and there are kind of 20 different hop species planted. But we are about to study just 6 of them in this test area. So we did kind of 2 different data sampling methods in the last August 2023. So at first there was a hyperspectral flight with UAV on August 23, and the day after we did a terrestrial chlorophyll measurement on August 24. And what we used therefore was a chlorophyll meter SPED 502 plus, which we kind of used to regain some values about the SPED values. For the hyperspectral data sampling, we've used UAV. The type was a DJI M600 Pro. And the sensor, which was equipped, was a nano hyperspec of the hyperspec family of Headwall photonics with 400 to 1000 nanometers range. All about the area was flown in 7 lanes with an overlapping of 40%. And for the tile scanning, we use a push broom scanner. And on the date of flight, we had kind of no cloud formations or hardly any cloud formations, which kind of resulted in some shadowing, which I'm going to present you on a later on slide. So as a result, at first I want to go have a quick look at the terrestrial chlorophyll measurements, the SPED values. And as you can see, I've got 2 figures. On the one hand, we measured the plants on different height levels. And on the other hand, I present kind of mean values of the SPEDs for all plants together. But first, on the left side, to explain the different height levels of 150 meters, 250, and 4 meters, we have to say that every hop plant on this kind of test area is it's based on the ground and has 2 strains which is fixed on the top. So we decided for every plant we made like 12 measurements in total. So for every strain, we made 6 measurements. 2 were on each side at kind of 150 meters height. The next 2 measurements per strain were on 250 meters height, and the last 2 measurements were made per strain on 4 meters height. And per height level, we tried, on the one hand, we tried to measure the leaf which is kind of closest to the strain. And on the other hand, the other value or measurement we took was on a leaf which is kind of the most distant to the strain at this specific height level. So we gained like per plant 12 different measurements, which result on the right side. For example, for the pearl in the first row, for plant 1, in a mean SPED value of 44.9, for example. And this for every 18 plants per species with a mean value. And overall, I made a ranking for every hops type. So afterwards, we can see which kind of type was the best adapted at that point of measuring date to the according climate, which was at that date. The other big measurements we made were, as I already told, the hyperspectral flight. So as a result of the hyperspectral data sampling, I can show you this is a result so far. It's emerged hyperspectral raster within the wavelength of 796 nanometers to 810 nanometers. And the reason why I talk exactly these bands, band 60, band 61, and band 62, is because it makes it very easy to distinguish between a plant and its own shadow. As you can see on the smaller image on the right side, it makes it kind of easy because all plants are kind of highlighted in white and the shadows are about to be black. So I can, at the beginning of my research, I can start with pointing, for example, the plant on the bottoms, plant plant 2, plant 3, plant 4, and afterwards I just have to put the layers on and off to see where I'm exactly right now, because yeah, as you can see later on, it's not that easy to distinguish all the time between a plant or a shadow or the surrounding plants. So I'm gonna go in deep on that later. So for the indices, which I've calculated so far, a basic one, which is kind of more multi-spectral related than hyperspectral related, but it's always an important one is, in my opinion, the normalized difference vegetation index, the NDVI. And I've made these two figures because on the left side, I wanted to point out there's I made this with a linear color optimization, and as you can see on its corresponding legend, it's the area has very many plants. The vegetation rate is very high. So as you can see, the lowest values are around 0, kind of 0, which means there's a lot of soil or was kind of dry vegetation on the ground. But every hops we researched or we measured was kind of very well developed. So it's a total green area with this linear color optimization, and it's kind of hard to distinguish which plant is next to each other, and it's kind of different. So I went further on and used, for example, the a quantile color optimization, which you can see on the legend, and there you already can see that the range of values differs kind of very much. So, for example, the lowest value was on -1, and the highest values were kind of top to the 1. So we have a very big range in the lower values. But as we reach the top of the plants, and especially for the hops, it's kind of very easy to distinguish what's hop and what's soil. And surrounding plants, for example, just simple grass. So it's kind of easy to distinguish and to point at a specific plant and get an exact value which we wanted to get. And another two indexes I've worked so far are the water stress index, the WSI, and the normalized difference nitrogen index. Both are kind of very relevant when it's about the condition of a plant or the conditions of plants overall. On the left side, you can see the water stress index. If you zoom in, you can kind of distinguish very well what's a different plant. But on top view, yes, what I recognize now, it's kind of harsh to differ the hops or the surrounding soil or the small plants like grass, for example. It's kind of hard. I guess on the NDNI band, which is the band 76 and the band 50, it's around 725 nanometers and 900 nanometers, which worked out quite well. You can differ very well between different hops plants and the surroundings. And as you can see, the soil is all kind of highlighted in a white color, and all the hops in the middle are kind of good to distinguish, in my opinion. So you can point out and work really well on specific plants on themselves, because that's what I'm about to do on the further outlook. Because I'm about to calculate more indices correlating with the plant conditions on the one hand, and on the other hand, I have to evaluate hyperspectral data in relation to these indices too. And at the final end, I want to create a big tabular where I have listed all hops types on the one hand, and on the other hand, the corresponding spat values, for example, the chlorophyll values and every indices I've made so far. And at the end, I want to try to get to a conclusion to say which hops type was the best adapted to the date of measurement we made. So this might be an interesting thing for the future, corresponding to climate change, for example, and which hops types are kind of more adapted to a dry or quickly changing or rapid changing weather extreme. So this gonna be kind of interesting, very much. So far that's the most of my side. Here's a little presentation of of my literature and the illustrations I've made so far. And yeah, I hope this was kind of interesting for you and everyone. And yeah, thank you for your attention. And yeah, any questions?
Thank you very much, Daniel. Thanks to all the other speakers so far. I will let my marketing and communication colleagues, Marissa Dupont and Rosna Katsuji, moderate the Q&A session. I want to remind everyone again that there is a specific chat space where you can type your question. We will read it and we will comment that live. I guess there are some questions readily available. Marissa, would you like to start?
Okay, first question for Florian. Did your team try oblique view to deal with shadowing effects?
We didn't optimize the data therefore yet, but we also are not the most educated there. So I would maybe pass the question to Johannes or Christoph to give you more detailed information on how to avoid those things.
Yeah, maybe I can answer that as we perform the flights. So oblique, that means for those who are not so familiar that you change the camera constantly and try different perspectives. So usually a nadir, and we also combine nadir with a certain angle, and that is most of the time enough to create a good 3D reconstruction with the RGB data. And with the hyperspectral data, it's not that easy as you have a push broom sensor. So therefore, each flight stripe, you go line by line, and that is geo-referenced afterwards according to the EMU and the GPS data. And there you would not take like a cross-grid flight or a different angle. You just have to use the usable nadir perspective. But in most cases, that works well. Yeah, you have to correct for the plant position and structure, but that's more of a flight planning and overlapping of the flight lines that you have to deal with.
Next question.
Another question I may have missed and cannot hear, but what altitude was the drone flown and what was the sampling rate?
I'm sorry,
Marissa, you're echoing a bit. Yeah, you're echoing a bit. There must be some Larsen or something.
Do you want me to? Hi, sorry about that.
Okay, good now.
Okay. The person may have missed because they can't hear, but it says, but what altitude was the drone flown and what was the sampling rate?
So I think, please correct me, Johannes, if I'm wrong, but for the RGB flight, we flew at around 50 meters, and for RGB, we also flew on around 50 meters.
Yeah, I think it's not a fixed height. It was varied to some extent, like 50, 60 meters, but in this range, most of the times we flew. Yeah.
Do you remember the sampling rate, guys? Like the frame per second? Must have been a sunny day, right?
We already did this one.
It was, and it was not always full sun, but there were some cloudy days as well. But yeah, the images that Daniel has shown, I think it was most of the time sunny. Yeah.
Okay, it says, thank you for your presentation. Have you tried to use partial least squares regression to identify bands that better predict chlorophyll concentrations?
No, not yet. At the moment, we are just trying to. Yeah, we struggle quite a lot with programs we are using to evaluate the data because we have a high level of data security here at the State Research Center. So we are very limited in our programs we are using, and we just can use like basic vegetation index like NDVI at the moment, but we're planning on doing those things in the future, and we hope we can further improve our gained knowledge on the data.
How long will this project continue?
The verticillium research project will continue until 2026, and the CBCBD research project, which is also part of our remote sensing questions, is continuing to until 2027. But we think we can we will extend it until 2029. And a small part is also, so like we do other things in those research projects, but there is always a little budget for our remote sensing activities.
Was the rotor wash wind a problem flying over the plants?
Should I answer?
I'm not sure if I got the question right, but no, actually, I don't think that this was a problem. Johannes, maybe you can help me here.
Yeah, no, not at this site. Usually, depending on the wind conditions, but the wind angle and the wind direction, but 5 to 10 meters with the M600, it's quite a big bird. But there you cause the turbulence with the downwash of the rotor wings. But if you're flying higher than that, above your target vegetation, you don't have to. There's no much effect of the turbulence created by the rotors.
Again, for drone pilots, how long was the duration of the flight? And if broken clouds were present, did you apply any correction for changes in the ambient light to improve your orthomosaic?
So a normal flight time is 10-15 minutes in this area. We will extend that with the use of the M350. Like I said, in the former time, it was the M600. Usually the calibration is done with a calibration tarp that is placed in the field. And there, of course, you have to pay attention that the flight conditions, the lighting conditions are constant. So, of course, that is the worst case if there's 50% clouds and 50% like sun. So those conditions have to be avoided. So usually we have to look and on the Monday, what's the best day in the week suited for this task? But then we choose one. Either it's constantly cloudy, like Francesco already said, you have to adjust for the frame rate of the sensor according to each condition. But then you have the exposure rate and everything that fits to your conditions. The calibration target has the same conditions during the flight, and normally there's no problem for 10-15 minutes to get equal conditions.
I'd like to add something here because we are still using the remote sensing technology in field trials. We are only covering a small area, ground surface area. So like most of the hyperspectral imaging flights took around like 3 to 5 minutes. So that's a time amount you can have. Most of the time you don't have any clouds.
Did you run into any data storage issues? And are there plans to expand the covered area? And if so, is there a data storage plan?
So right now, yeah, we actually ran into data storage problems because we stored it all at our server, and it was actually full pretty quickly. And we were asked to use like portable SSD devices, which we do right now. We have to use the NVMe versions here because of BitLocker issues and slow data speeds. But otherwise, yeah, maybe we can decrease the amount of data we have to collect by limiting the spectral bands in the future when we know on which bands we are actually looking. But for now, in our trials, we rather have a big collection of data for evaluation. And in the future, when we do bigger trials and bigger bigger areas, that will take part when we have more limited bands.
Another question for Florian. I guess it will be challenging to see pests from a drone platform. Any thoughts on this challenge?
Therefore, we are not looking for each pest directly, but we are looking for induced reaction of the plant when it's starting to be infected with the pest or disease. So like something you can see with your eye, but maybe you're able to see it on the hyperspectral band. And therefore we don't have to see a single pest or a single fungi, but we can see the reaction of the whole plant, and we are able to see the single plants from the drone side of view. So we hope this will be possible, yes.
The near part of the hyperspectral image, especially 800 to 1000 nanometers, has a lot of noise, especially when taken outdoors using a drone. Can I get some advice on this?
So I think that question is more directed to Johannes, because we only do like the analyzing part, and we get the already processed data from geo-konzept.
Christoph, would you mind to elaborate a little bit on that, because you're more experienced in the post-processing, but there's the calibration and the correction takes place.
Of course, no problem. Yes, of course, you're right. We are close to the edges of the spectral sensitivity from for example, from the nano hyperspec sensor. We get some noise, but one of the post-processing steps, of course, is the radiance calibration or correction, and also the reflection calibration. And we can filter out a lot of this noise, but noise is always there. And you will see it also in the data, of course, and it's yeah, it's well known, and that's physics. And the post-processed or the export NV data set we used, or which one we transformed to the orthophoto, looks nice in the complete spectral range between 400 and 1000 nanometers. I hope it's a good answer to your question.
You may have just answered this, but
course,
what wavelength ranges did you take?
You're welcome to ask for sample data to the one who's asking that question. You're welcome to get in touch with us and ask for sample data. We have some sample data sets available if you want to have a view of them and evaluate by yourself. Sorry to interrupt.
Oh, no worries. So what wavelength ranges did you take from the air?
From the air, we took the bandwidths from 400 to 1000 nanometers.
And last question, how can I arrange for flights by the CHRSE over my own test plots?
That's very easy. Write us an email or give us a call. Or we are also very happy to discuss your area of interest, or your idea, or your project, or whatever you have in your mind to do a hyperspectral test flight or project flight on site on your area or field or whatever. We can do 99.9%.
What does SPAD stand for?
Soil
and plant activation device or something like that. But I haven't the exact definition. I don't have ready.
Okay, it's actually a system to analyze the fluorescence intensity fluctuations. But basically, it's about irradiating with artificial light the plant and measuring the decay of the fluorophore. It's basically a way to measure fluorescence.
Yes.
What kind of intercomparison were you able to do with the outdoor flights and the indoor scanning on the MV-scan setup with the Headwall hyperspectral imaging system on the per-class mirror scanning stage?
Until now, we don't know direct comparison between the between the stationary sensor and the data we derived from the UAV sensor. So I can't give you any information on that until now, sadly. But we work on this one, and we try to compare them later, maybe in the next years.
Could the flights have been done with a DJI Matrice 300 or 350 model UAV instead? These are newer but smaller models with more limited payload carrying capacity.
I would hand this question to Johannes because he's the expert on, or Christoph, because they are our experts on the drones. So we don't only like the data acquisition, and we only did the evaluation later.
So yeah, the flights so far were done with a DJI M600, but as some of you might for sure know, the 600 is discontinued, but the M350 is available, and we offer to mount the Headwall Nano on the M350, and this will be the flight for this year will be performed then with the M350, as it has, like the questioner has mentioned, has more flight time and more flexibility regarding flight planning. Christoph, if you want to add anything.
Okay. How do you utilize the chlorophyll fluorescence measurements?
Oh, that's for Daniel.
Oh.
Yeah, this is mostly for Daniel. All I can say about chlorophyll fluorescence is that a lot is going on in regards to correlating fluorescence to predicting yield of plants, gross primary production, and stress. So a lot of this is being done, and some of you might want to follow the ESA Flex mission user group, the European Space Agency Flex mission user group. They are very much into that. But of course, Florian can elaborate. Daniel could elaborate further when he's back. So we will make sure that we pass on this question on to him.
In this trial, our aim was also to, since it's a field trial from our hop breeder, so the whole area is treated with the same amount of nitrogen nutrition, and the SPAT values and the hyperspectral data is also an indicator on how efficient the plants with the different varieties there can collect the nitrogen from the soil. That was also one indicator for the nitrogen use efficiency.
Okay. How did you select the specimens to scan on the scanning stage? Was there a methodology?
So yeah, we scanned healthy and diseased plants beforehand, so we could mark some spots on per class Mira, and we scanned healthy plants, respectively leaves, after the inoculation again. For the not visible part, we are still looking for a way to analyze the data, but yeah, that's how we did it on this point.
What is the ground sampling distance of the nano hyperspec? I was impressed that the map was created with only 40% overlap.
Okay, we could run a quick calculation. If you remind me at what altitude you flew at with the 70 millimeter lens, right? Or was that a 12, Christoph, or a 17?
It was done by the 12 millimeter, and height was between 50 and 60 meters.
Okay, let's say 60. Okay. Yeah, okay. 60 meters altitude above the ground provides roughly a 3.7 centimeter GSD, spatial pixel. What is told about overlapping is that generally push broom, well, we didn't get through that technically because we wanted to give more room to lectures in this webinar, but we may elaborate that further in a second in another webinar. But the way push broom scanners work, it doesn't require any particular overlap to generate lateral overlap to generate the mosaic. The lateral overlap is just there to prevent any missing gap between parallel lines. But it's not like photogrammetry. It doesn't work like photogrammetry when you make a mosaic. You don't need that overlap to generate the mosaic. It's just there to avoid getting any gap in the measurements between parallel lines.
Okay. What were the reasons for choosing those particular species of hops?
We used varieties which were relatively newly bred and compare them to more older varieties to see a better difference in the progress of the breeding, of the whole breeding program. And we also chose the varieties which are most important for us because they are grown on a lot of surface and have a high percentage in market share.
How do you deal with differences in dynamic ranges amongst different bands?
Is that related to changes in the illumination or?
I think so. Exposure. Yeah.
Okay. Christoph or Johannes, you are there in the field. Would you like to take that?
We are also using for the reflectance calibration and reflection TARP with defined percentage of reflectance level. You can choose between three levels, and the TARP need to be in the area of your area of interest. It's the best solution, but you can do it otherwise as well. But that's the second step. Second step in the post processing. The first step is the radiance calibration. It's done with the dark images by with the nano. It's only a very easy click. The most important thing in this case to don't forget the cap on the lens. And the second step is the reflectance, reflectance TARP in the area of interest, and it's one of the two steps in the post-processing to get the NV data cube. The last is the auto rectification. And about the exposure time, during these flights we had very nice sunlight conditions. Only some clouds, if I remember correctly. Johannes or Florian, correct me if I'm wrong, but it was last year in the middle or end of August, and we had very good weather conditions. And the hop yard it's not a very big area, and the flight was done in 5 minutes. That's one of the shortest part in this application to collect the data over the hop yards. I hope that answers your questions. If not, let us know, please.
Last
we
question.
have room for another question. Okay, thanks. Yeah, sorry.
Yep, last question. What are your conclusions?
Conclusions on what? So yeah, like I said,
Yeah, are there any?
We see the high potential for us. We don't know yet if the technology is coming to each hop farm, since hop is it's highly intensively work to cultivate the plants. So each farm, each hop grower has only like I think the average hop farmer is cultivating about 20 hectares, 20 to 25 hectares. And since the technology is pretty expensive, I don't think every farm will buy this technology. But we have a very good consulting facility, and I think those our colleagues there will surely be possible to use this kind of technology, and if we make a big enough of an advance, I'm pretty sure this can be used in hops.
Okay, so thanks for all the questions. As a follow-up to these questions, I just have two quick comments. Comment number one, the quick calculation I did on the pixel size, on the pixel resolution, was based on our free online FOV calculator. I invite you to visit our website, library tools, and use our FOV calculator. By that calculator, you could virtually plan all your mission and decide upon which lens fits best for your camera, which camera is more ideal for your work, and see how you could cover your area or your area of interest, and how much time that it takes based on all the factors we discussed during the question. The second comment that I'd like to make is related to the very last point we made. Consulting and servicing. Headwall and the CHRSE offer a service, flight services for clients. So we are happy to support customers that cannot justify an investment to buy a camera in the short term by offering a flight service over their area of interest. So please don't hesitate to contact us if you're interested in that kind of service. That said, I would like to point out the next events where we could have a chance to meet you in person. The European Geosciences Union General Assembly, that's happening in April in Vienna, the EGU. The CHRSE will be there, and the Headwall will be with their Spanish reseller Grupo Alava at the next ERSL workshop on imaging spectroscopy in Spain, again in April. That week is going to be a very busy one for Headwall. Last but really not the least, I want you to stay tuned on our website, because we will be happy to invite you to our next CHRSE workshop at the geo-konzept site in the heart of Bavaria in the fall this year. So please stay tuned. The invite will be released shortly. We hope to see you there. Thanks very much for attending the show. Again, I want to remind you about the email you could use to contact us, marketing@edwardphotonics.com, or you could simply visit our website and click contact to be connected to the reseller which is covering your area. I want to thank all the presenters today, Florian, Daniel, Johannes, Christoph, and our Marco manager, Marissa and Ross, for supporting the event. Thanks very much for being online with us today. Take care.